Imagine, just for a second, peering back through the absolute darkest depths of space. And I don't mean just a few hundred years or even a few million. We're talking 13.5 billion years back into the glowing, starry past of our universe, literally catching the very first luminous glows right after the Big Bang.
It sounds totally like science fiction, right? I mean, it really begs the question, how exactly do you build a time machine? Because, well, in astrophysics, seeing ancient, impossibly faint light from across the expanding cosmos, that is exactly what that is. It's time travel, and catching that light requires the ultimate engineering solution.
So, welcome to The Explainer. Today, we are diving into the premier, honestly mind-bending marvel of the next decade of space exploration, the James Webb Space Telescope. This thing isn't just an observatory. It's a massive leap forward in our quest to understand exactly where we came from.
Okay, let's dive into our roadmap for today. First up, the ultimate time machine. Then we'll look at engineering the impossible, followed by hunting early galaxies and exploring alien atmospheres. Finally, we'll wrap up with how you can actually do NASA science yourself.
All right, Section 1, the ultimate time machine, looking back to the Big Bang. To study the absolute dawn of cosmic history, we need a very special vantage point.
Webb sits at what's called the second Lagrange point, or L2. Now, this is a special gravitational sweet spot in space about 1.5 million kilometers from Earth. Why so incredibly far away? Well, Webb is hunting for ultra-faint heat signatures from the early universe. To actually see them, it has to be far, far away from the massive amounts of heat and light bouncing off the Earth and the Moon. So it actually orbits the Sun, pacing right alongside us.
Just to put that massive scale into perspective, we all know and love the Hubble Space Telescope, right? But Hubble orbits a mere 560 kilometers above Earth. Webb is at 1.5 million kilometers. It's just a completely different paradigm of space exploration.
And from way out there, Webb is tackling this insanely diverse science checklist. We're talking hunting the early universe's first light, tracking how galaxies evolve over time, observing the life cycle of stars, and even peering into completely other worlds. It is the ultimate multitasking masterpiece.
Moving on to Section 2, engineering the impossible, building a space transformer. Let's say you've designed the world's most powerful telescope. How on earth do you fit something that huge into a rocket?
Well, you basically build a space transformer. To fit inside the launch vehicle, Webb had to be folded up, kind of like high-tech origami. After it launched back in December 2021, it spent weeks slowly, carefully unfolding in deep space. And here's the truly nerve-wracking part for NASA engineers. It had to unfold perfectly on the first try. There was zero chance to send astronauts up to fix it if something got stuck. It was this flawlessly executed sequence of brilliant engineering just to safely deploy its mirrors and unroll its massive sunshield.
Speaking of that sunshield, think about this number for a second: 1 million. Webb's 5-layer sunshield is roughly the size of an entire tennis court. Its job is to protect those ultra-sensitive infrared instruments from the blistering heat of the Sun, Earth, and Moon. It literally acts like sunscreen with SPF 1 million. Without this extreme shade, the telescope's own internal heat would completely blind its sensors.
Then there's the mirror itself, which is just absolutely iconic. Webb uses 18 brilliant gold-coated primary mirror segments. Now, why gold? Because gold is incredibly efficient at reflecting infrared light. That's what allows the observatory to catch those ancient, impossibly faint photons that have been traveling from the distant universe for billions of years. It really is a triumph of engineering design.
Which brings us to Section 3, hunting early galaxies, finding little red dots. So what exactly happens when all this impossible engineering works perfectly? We get the massive payoff of Webb's unprecedented sensitivity. Webb is actively solving the puzzle of how early galaxies formed, spotting what astronomers affectionately call little red dots. It's finding strong evidence for wild concepts like black hole stars and capturing the deepest spectrums we have ever seen, meaning it's pulling dozens of unique chemical fingerprints, spectral features, out of a single tiny dot of light. It's completely rewriting our understanding of the early cosmos.
All right, Section 4, exploring alien atmospheres, roasting planets, and alien air. Because Webb isn't just looking deep into the past, it's also checking out our stellar neighbors.
Just as a quick refresher, an exoplanet is simply a planet orbiting a star entirely outside our own solar system.
Webb is perfectly equipped to stare at these distant worlds, analyzing the starlight filtering through their atmospheres to figure out their exact weather and chemical makeup.
And let me tell you, sometimes that weather is absolutely wild. Webb literally caught an exoplanet, HD 8606b, getting completely roasted. As its highly eccentric orbit brought it incredibly close to its host star, a blistering point called periastron, Webb just watched the immense heat absolutely blast the planet. It's this incredible mini-narrative of stellar dynamics caught right in the act.
Webb is finding these chemical fingerprints literally everywhere it looks. Using instruments tuned to mid-infrared light, which is basically heat radiation invisible to human eyes, it detected methane on an interstellar comet. And it's supporting the search for life beyond Earth by scanning exoplanets like K2-18b. The precision here is just astounding. We are actually reading the air of alien worlds light years away.
Finally, Section 5. Do NASA science yourself. Be a galaxy explorer today. Now, I know a lot of this science might feel like it's strictly for folks with advanced astrophysics degrees, but that is simply not the case.
You really don't need a PhD right now to contribute to actual space science. NASA actively invites people of all backgrounds, especially students, to participate. Through a citizen science project called Galaxies, you can actually jump online, look at brand new, pristine images of galaxies taken by the Webb telescope, and help classify them.
I absolutely love this direct call to action from the project. Join NASA researchers and help discover the secrets of the universe. Volunteers and students have already helped make thousands of important scientific discoveries. By categorizing the shapes and structures of these galaxies, you are actively helping researchers process the sheer avalanche of data Webb is sending home every day. They literally need your help for this.
So think about it. We have a time machine orbiting 1,000,000 miles away. An origami marvel of gold and supercool technology beaming back views of the universe that no human eye has ever seen before. The tools are online, and the universe is waiting. So the only question left is, what will you discover?